All right, this is Sam from Group 8, beginning our Chapter 22 presentation, Information Security is Everyone's Job Every Day, and how we can incorporate that, make that a reality. The first thing that you can do is to integrate security into development iterations. And the problem that's currently seen is that incorporating info security at the end of a project causes the most expensive blockages to deployment. So the solution is not to implement it at the end, but to implement it throughout. And that's by inviting the info security teams to be part of development. And this allows them to better understand team goals, observe their implementations as they are built, and provide guidance and feedback at earlier and cheaper stages of development. The next thing that can be done is to integrate security into defect tracking and postmortems. And that kind of sounds like a mouthful, but the main problem is that security vulnerabilities are stored in a GRC, Governance Risk and Compliance tool, that only info security teams see. So the solution is pretty simple. You just incorporate that tracking system into the DevOps tracking system, what they're currently using for transparency and prioritization. The next thing that can be done is to integrate preventative security controls into shared source repository code, or into shared source code repositories and shared services. And this kind of harkens back to trying to have cumulative knowledge by using a shared repository. By doing that and incorporating pre-approved and supported security tools and mechanisms, this provides the following benefits. Shared security libraries will be adopted by all DevOps engineers because they're available to everybody. The security tool updates are visible to all, so any changes that are made will be seen by everybody. And security reviews will no longer be needed because they're using pre-approved mechanisms.
Integrating security into a deployment pipeline via automated testing as opposed to handing out large PDFs listing vulnerabilities can reap the following benefits. It puts security testing in a framework they are likely already familiar with. It allows security tests to easily run in a deployment pipeline on every committed change. It enables both dev and ops to quickly detect and correct security problems as part of their daily work, and it enables learning and prevents future errors. As part of automated testing, we'll want to include static analysis in a non-runtime environment. It inspects code for all possible runtime behaviors and seeks out coding flaws, backdoors, and potentially malicious code. It also involves testing from the inside out and is sometimes called testing from the inside out. Additionally, there's dynamic analysis, which is tests executed while a program is in operation. It monitors system memory, functional behavior, response time, and overall system performance, and is commonly referred to as testing from the outside in. Additionally, there's dependency scanning, which is another type of static testing. It involves inventorying all dependencies from binaries and executables, ensuring these dependencies are free of vulnerabilities and malicious binaries. And lastly, there's source code integrity and code signing, which ensures developers have their own PGP key that all commits to the version control are signed. Many companies utilize existing code, utilities, resources, and dependencies from the internet in their projects, be it open source or commercial. While these might make things easier and save time, the side effect of using existing libraries is that you inherit not only the benefits but the vulnerabilities. For this reason, it's important to choose providers that are known to quickly patch vulnerabilities when they are discovered, and choose dependencies that we know are secure.
This is Alyssa Hundley, and the section I have is ensure security of the environment. So what we want to do is everything necessary to make sure our environments are in a hardened, reduced state. So we want to include monitoring controls that ensure all production instances match these known good states. So we're going to generate automated tests that check configured settings for hardening, database security, key links, etc. We're going to use tests to scan environments for vulnerabilities, and we're going to understand actual environments. And some tools that we can use to do that are like Nmap and Metasploit. And so these tools, like these two examples of tools that I mentioned, the output of these should be put into our repository and compared with the previous version as part of our testing process. And by doing this, it'll help us detect undesirable changes as they're occurring. They're super important. We want to catch them while they're happening. It'll be a quicker fix. It'll help us know exactly what happened in that moment so that we can avoid that in the future as well, not only fixing the error as they occur. I really like this example from the book. Marcus Sachs, one of the Verizon data breach researchers, observed in 2010, year after year, in the vast majority of cardholder cardholder data breaches, the organization detected the security breach months or quarters after the breach occurred. Worse, the way the breach was detected was not an internal monitoring control, but was far more likely someone outside of the organization, usually a business partner or the customer, who notices fraudulent transactions. One of the primary reasons for this is that no one in the organization was regularly reviewing the log files. So, this is a very real example from Verizon here, or Verizon data breach researcher, I should say, says that these errors that are occurring here or breaches that are happening, we're finding out about them outside of the organization. We're not finding them here at the company before they actually occur in prod, but it's somebody else that's discovering them. And that is a big no-no. That's not what we want to happen. We want to discover them before. So like this topic is integrate information security into production telemetry. We want to do this. It's an internal thing. We want to find it before it gets out. So we want to make telemetry and metrics visible so everyone can see how our services are performing in production. Ops, development, security, everyone should have access to seeing how they're performing in prod. Relentless seeking and fixing the problems before they result in a catastrophic failure. So that is the goal. We want to seek them, find them before something bad happens. And integrate our security telemetry into the same tools that development, QA, and operations are using. And we want to see how their applications environments perform in a hostile threat environment. So this integrating these security telemetry into the same tools that dev, ops, and operations are using just is like the first goal here. We want to make sure that everybody is aware of what is going on. This is why we keep all of the tools and information in the same place. And we also want to keep track of how the tools that development is building will react in this threat environment. Okay, the next part is creating security telemetry in our applications. So we want to create telemetry in our environment to detect early indicators of unauthorized access. We also want to confirm that we are sending telemetry to the right place, and we want to potentially block access and store information about the source of an attack. We need to monitor and potentially alert on items, including the following. So these examples: OS changes, security group changes, changes to configurations, cloud changes, XSS attempts, SQLite attempts, and web server errors. So these are just examples, but I love how this says here that all of these changes that we want to monitor and alert. As long as we are aware when changes are happening, then we can avoid a catastrophic failure, like mentioned before. And we want to protect our deployment pipeline. In order to adequately protect the integrity of our applications environments, we must also mitigate the attack vectors on our deployment pipeline. So risks of this are that developers introducing code that enables unauthorized access and unauthorized users gaining access to our code or environment. And this, hopefully, if this happened, it would just be a mistake and not an intentional thing, but these are two things that we want to avoid. And so these can be mitigated when we have code testing, code reviews, configuration matching good states, and effective patching. And so here are some mitigation strategies. Hardening continuous build and integration servers, reviewing all changes introduced into version control, instrumenting repository to detect when text code contains suspicious API calls, ensuring every CI process runs on its own container or VM, ensuring the version control credentials are read-only. So we have many different strategies to protect our pipeline here, and these aren't usually this isn't just pick one and you'll be good. This is a good thing to implement every single one of these strategies. And here is our reference. Thank you for watching.